ahead and jump into your talk.
Okay, so before I do it, let me share my screen first. I hope you guys see the slide I am presenting. The title is DevOps, What, Why, and How. And everybody can hear me okay? So little bit about me. This is my second time I'm presenting for City University. So first of all, thank you so much for having me. I have like close to 18 plus years of industry experience, and at present, I am working with the T-Mobile Bellevue headquarters as a principal architect. I work for B2B group, which is business to business. We call ourselves T-Mobile for Business. I am Microsoft MVP since 2014. I do have a C# Conv MVP award since 2013. I am TOGAF certified architect. I am also a certified Scrum Master. I have a certificate in project management called CAPM. I have given like almost a dozen Microsoft certifications on the technical path. And I am a published author for these 5 books you can see at the bottom. And then I am also an active technical reviewer for over a dozen books, as you can see on the right-hand side. I'm still reviewing a couple of books for A-Press as well. So this is a little bit background about me, and if you need to learn more, you can always reach out to me. My coordinates will be available on all the slides. So before we really get into DevOps, like as the title says, DevOps, what, why, and how. In today's world, it is very important for us to understand how all these companies are really disrupting the market and what software practices they are following to really call themselves that they are a high-performing software organizations. In industry today, if you see anywhere, regardless of which company you talk about, no matter what their domain is, they all are running on heterogeneous devices and platforms. You cannot just say that I will only cater the customers who is running on a Windows laptop. Today's websites are built in such a way that they are so responsive that those websites are opening the exact same manner on my Windows laptop, on ThinkPad, in Chrome browser, and equally well on a Mac in Safari. Similarly, on a tab in somebody's hand. All the organizations are today using hybrid IT. Those days are gone when people would say, we are only on premise. Every single server is running under my desk, and all our softwares and applications are running on the server, which is sitting right here under my desk. Today, we do not have infrastructure, and even if we do, we always go hybrid. Means we do have cloud, as you can see on the second box above hybrid IT and data centers. We, T-Mobile, are pretty much over there. We do have our own data centers. We have 2 data centers. One is in Washington, one is in Texas on West Coast and East Coast. And we also have a huge deployments in the cloud on AWS, Amazon Web Services. Like us, there are many other organizations who follow the same pattern when it comes to the deployment. Also today, teams are distributed. Like many companies has announced, they will be working from home completely, which is influenced and motivated decision maybe by this pandemic worldwide. Now, having said that, teams are distributed. We at T-Mobile have offshore teams through our vendor partners. We do have our own teams in Atlanta, and after this recent Sprint merger, we have got team in Kansas. Now, in addition to that, we have team in Bothell, Washington, and then we have few more offices in Bellevue, and then in Sammamish, and things like that, right? So teams are already distributed. Now, how do you collaborate with them? How do you work together with those teams? Now, all companies are going in that direction. And the most important factor today is to really deliver agility, that whatever you want to do, you want to deliver fast. You want to deliver quick value to the customer and be agile. You want to be continuously moving and deliver value to the customers. Now, these are 4 things, I think, which really set the stage to understand what sort of software practices we need to follow in today's world. So keep these 4 things in mind. I will repeat one more time: heterogeneous devices and platforms, hybrid IT, distributed teams, and we want to deliver agility at the end. Now, this is about DevOps. Now, always keep two words in mind, as this word itself can segment, and if you want to dissect it, it is DevOps. Means there are two words which are being combined in DevOps. One is developer and the second one is operations. Now, before I really dig deeper into it, what happens in industry, I come from a developer background and then how I became the architect. So developers are the one who write code, who fix things, who are problem solvers, and they will make a website, applications, APIs, programs, apps, applications, all those things, they really bring those to life. Now, then there is second side in the house, the people who really deploy it to the server, who really own the infrastructure, whether it's a server in your data center, it could be a server in the cloud on AWS or wherever, whatever cloud provider you use. Now, they own how your application will be deployed. Did you give me the guidelines how to deploy it? You may have a database script, let's say SQL script, that you need to deploy a new stored procedure, or a new table needs to be added, and that table is being connected to your website or application. When you deploy it, the website and the database changes, and these two things connect together, it will work beautifully. So operations people do that part. Now, what DevOps does, DevOps means bringing these two hats or these two feathers to one head, means putting multiple hats on the head or putting two feathers to one cap on somebody's hat. So think in those lines, bringing these two things together. I have been in both the situations. In my prior organizations in the recent past, I was working with a company where I have myself played both the roles, but ops part was completely separate. Means I will write a proper detailed Word document. In the daytime, I will put my code, copy the bits, the executables, copy it, put it in a separate folder altogether, which ops person has access to. He gave me only just, the right access for temporary timing, and then he took it away. So I deploy all my files there. I put my SQL scripts there. I put all the things there. Then I write a document in the daytime or a few days earlier and say, okay, go to this folder, copy this file, and deploy to this directory. Open the SQL script, copy it, go to SQL Server, paste it there, run it, and see a table got successfully executed. Now, if you have any experience in these basic things, you will understand what I'm talking. So the person who wrote the code, that was me, and the person who is deploying, someone else, are two different people. They are not the same people. Now, the problem here is, which happened many times, I have been on those calls in the night, because most of the companies deploy in the nighttime, because that is when your business is low, especially in US. But if you are like a worldwide customer base, then you have to deploy in phases. Like if I have a website running in India, I will not deploy it when India people are up, right? So today there is almost 12.5-hour difference between India and US time. So similarly, I will not deploy a website in United States of America anytime when business starts, whether Eastern time or Pacific time or Central time, whatever, when there is a business time. So what most of the companies do, they start deployment like around 9:30 p.m. Pacific. Means it's already midnight in Eastern time. And in Pacific, no store is open. So there is a window for 1 hour or 2 hours when we take the site down. If you go to tmobile.com or amazon.com, you won't see much happening there. And then we deploy the new changes. We work with the ops person. That person will write the code, do the changes, and then things happen. If anything fails there, then ops person will say, oh, developer did not do right thing. Or developer will say, you know what, ops did not deploy properly. So what DevOps does basically, this is what DevOps is. So first thing to understand that in software field, we know that all softwares can be purchased. You buy licenses for. But remember one thing, that DevOps is something you cannot buy or install it. DevOps is not that. Instead of that, DevOps is a culture. And what happens in this culture is that this culture brings a people, process, and products together to enable continuous delivery of value to our end users. Means you are really being customer focused, customer mindset, and you are bringing people, process, and products together to enable the continuous delivery of value to the end customers. That is what DevOps is. Hence, it's a culture. There is no tool or nothing you can buy altogether as a packaged bundle and install in your computer systems. Now, as you can see on the image below on the left side, there is a dev and there's an ops, and dev has a small box in the hand. And that is what I was trying to portray the picture when I was talking earlier, that developers always build something and then they will throw over the fence to the operations people. Okay, here you go, deploy it. But operations doesn't know how your code works, what technicalities went behind, how to debug it or fix it if they run into some issues. And many times deployment has failed in the midnight when developers already went to bed. So as you can see in the middle, there is an orange line. It says wall of confusion. And that is pretty obvious that, of course, there is a wall of confusion because both the sides do not know each other's thing. Nobody has put themselves into other person's shoe. A developer does not know what operations actually need and what they do. And similarly, operations doesn't know how developers write code, what questions I need to ask them. They just rely on each other that if I give you a document, you will be able to figure it out and do it. And ops think developer will give me perfect document, written every single thing. But no, this is not how it works. I have been in those situations. So what this wall of confusion does, this wall of confusion has created a lot of mess around with people playing with it, and it was not very productive. So what DevOps culture does, it breaks the wall of confusion between teams, and it fosters better communication and collaboration throughout the application development lifecycle. Application development lifecycle means that when you deploy the code, you build the code, you test the code, and you really deliver it up to the production. Now, with this entire process, what happens is you are delivering software more frequently and producing higher quality software. Why you are able to deliver more frequently? Because you are bringing dev and ops together. So there is no wall of confusion. Same team is doing it. One person can own these things. And then the person who writes the code also can own the deployment of the code. There are not two different roles which own it. At T-Mobile, at Amazon, many other companies, you name it, they all have it. Netflix, Facebook, Amazon, Google, T-Mobile, all these companies, any high-performing software organization today is following DevOps. In our team, I have worked with payment and order management in the previous thing. We have the same pillar in my current team as well. Activation, account management, payment, order management, security, all these different pillars we have in a team. Every team is a sort of DevOps team, which consists of like 7 to 10 or 12 people. And all those people are together responsible to work together in a DevOps fashion and continue delivering value to the customers. With DevOps, what you do is you shorten the lead time and software delivery cycle. A lead time means that how long does it take for you to receive the requirement, understand the requirement, write the code, test it, build it, deployment, right? All these things are considered as a lead time, that how much time do you need? So with this DevOps process, it really shortens the lead time and it reduces the software delivery cycle process as well. It reduces the friction between the two. Now, this is something I really want to share with you guys, that how does DevOps workflow work from planning to release. So we start in this entire diagram, we start from the top left here. This is where user or stakeholder is, and they define or ideate what actually they are looking for. So at T-Mobile, business team defines what they want. They represent customer, end customer, like you and me, if we are consumers. So they define what customer need, what sort of plan, marketing promotions and all. Now, once they define something, it goes in the product backlog. It's an agile term. Scrum is the methodology for that. You can use Kanban, whatever methodology you use. At T-Mobile, we follow Agile Safe. So there is a backlog. Backlog is nothing more than a long list of work items, tasks. We call that user story. I can take a separate session on Agile, but I'm giving a little bit background about these things. So when you go back, you have some understanding about it. Now, you start on this backlog, and then there is a dev team. Here is a development team, right? So development team develop idea to working software. So they take the idea here, they will pick one idea from here and start implementing it. You see this cycle going? They start implementing it. Usually this cycle of implementation in agile terminology in the world and industry is called as a sprint. As you know, a sprint is when you run for a short distance. So a sprint can be 1 week, 2 week, 3 week, or 4 week long. At T-Mobile, we do 2-week sprints. Only for 2 weeks, we will do whatever we can. And there are entire set of people working in a team, and then we implement it. After that, we do continuous value of delivery. We deploy it. After deployment, we monitor it, that how it is functioning. Is it feature is broken or not? All API responses are coming nice and clean. No customer interaction is broken. Website is up and running. We have dashboards to validate that all the time, verify it. And then that is the operation side of it, right? You are operating it, working software in production, value realization. And if there is anything broken, for example, one API is giving hiccups, then we work on it. We take the learning back and put a user story back in backlog that, okay, I need to improvise the performance of this API so my customer can get faster response. So this is to summarize that how DevOps work. And as you can see, operations people come here in the picture, but this set of people and this set of people are diagonally opposite to each other, development and testing and operations. They are part of one team. They work together day in and night. That is what DevOps is. But the old model is operations people, you never meet them, you don't know them, you don't work with them. They are all totally separate group, distant apart, and you are a separate team, and you throw stuff over the fence. If you recall the previous image I was showing where you have wall of confusion. So these two people working together brings a lot of synergy and value to the team. Now, what happens is that team without barriers. So what was the barrier? Barrier was that wall of confusion we had, right? So if there is a team without any barriers, they deliver continuous value. And with this DevOps functionality, what they do, they collaborate better, they integrate better, they have faster cycle times, and then they can have a more realized value at a reduced cost. Revenue growth goes high, and they have faster time to market. Now, there are a few things I really want to tell you about DevOps practices. There are few practices which everybody should know about DevOps. If anybody asks you what is DevOps, you know DevOps is the union of a people, process, and products. DevOps is something you cannot buy and install it. DevOps is a culture. And since I mentioned it, let me also tell you one thing, that DevOps is a culture and Agile is a mindset. So most of the companies are following DevOps culture with Agile mindset. So we at T-Mobile are doing it. In DevOps, there are certain practices everybody should know about. The bare minimum. There are many more, but the bare minimum you need to know about is CI, or continuous integration, the first one, as you can see on the screen. Second one is continuous delivery, or CD. The other one is continuous deployment. Then infrastructure as a code, test automation, application performance monitoring, continuous testing, and many more are evolving in today's world. Now, what is continuous integration? Continuous integration usually is that you write code. The moment you write the code, that code is automatically integrated into a shared repository where all the team members are sending their check-ins to, their commits. So you write code, you don't want to keep that code with you. You want to commit it to a centralized repository where the rest of the team is working. Let's say we have a website. On that website, I have a home page, contact us page, and about us page, right? Home, contact, about us, these three pages. At any given time in a team, not one person will work on all three. There are 3 or more devs who will work on these 3 pages to do that stuff. Can you write this thing on about page? Can you change our call center number? Can you add live chat link and all those things? Think out loud, whatever you can, right? Now, these developers are going and working on their user story to apply changes to those code bases. And all that will go to the centralized repository. Whatever you make changes, that goes to centralized repository. And continuous integration says that your code will integrate with the shared repository on each and every commit you make. So that is what your continuous integration is. Now, continuous delivery is known to be an extension of continuous integration. What continuous delivery says that, okay, the moment your code is integrated, compiled, all tests cases are run and everything looks good, if you want, you can deploy it to a non-production environment or production if you want. You can deploy it to dev environment. A QA is quality assurance, like test environment. You can deploy it to staging, like a near production environment. Or if you want, even you can deploy it to production if you wish to. Now, that is what is called continuous delivery, means being ready to deploy to an environment of your choice. Whereas continuous deployment is nothing more than continuous delivery, but with automatic deployment or promotion to production. Means the moment continuous integration happened, it will automatically deploy to the production. That is not the right choice all the time. Many companies, like we at T-Mobile, also do not do it. We need approvals from VPs and directors at times to deploy changes. Many companies do not do that with intention because you don't know what will break, whether it's the right time to deploy that feature or not. Maybe you are working on something, a marketing promotion, let's say, right? But you deployed it, you did continuous integration, and due to continuous deployment, it automatically got pushed to production, but you are not ready for that promotion yet. That promotion was not meant to go live tonight. Maybe it was for next month. So what you did, you are ready with that. When that time will come in future, you will deploy at that time. But are you ready? Yes, you are ready. That is what happened with continuous delivery. Now, fourth thing is infrastructure as code. What does it mean? Infrastructure means anything physical. You are deploying containers. You are spinning a virtual machine. You are spinning a serverless Lambda or Azure function. You want to spin a website. Now, all these things are happening today, and all that infrastructure you need, you can write code for that. And whenever time comes in future to automate it, you can run that script and it will automatically spin a virtual machine for you. So rather than you clicking on the boxes in Azure or AWS and clicking on links, those scripts are ready and you can spin all those things. For example, in your DevOps practices, you will say, okay, to deploy this website, I need a virtual machine. So prerequisite is to have a virtual machine. So in your DevOps practice, you will write the script to create a virtual machine, spin a virtual machine first, and then once it is successful, then deploy the website on it, right? So all these things can be done. Test automation is very important in DevOps practices. Test automation is important for every single team. Learn about test automation. The bare minimum you need to learn about is unit testing. It's a very important skill to have. In test automation, what happens in DevOps, that whenever you do something, you compile your code or whatever, you will run certain number of tests. Unit tests will be run, your integration tests will be executed, and based upon the success criteria, which you will define, that if 80% pass, then go to next. You can say if 100% pass, then only go to next. So you can define those guardrails or percentage when you decide to make next step and decisions. So test automation is a very important factor there. And then application performance monitoring. What it means is that whatever you do, you launch the website, you launch your applications, but continuously keep monitoring. There is a word for that. We call it eyes on the glass. Means you keep watching, you keep looking through the glass to see what is happening behind. We call it consistent monitoring and application performance monitoring. So these things, what I just said, the top three: continuous integration, continuous delivery, and continuous deployment. I wanted to show you in a visual here as well. So developers commit the code. Commit the code means check in the code. They submit their code changes. There are more steps involved here, like somebody will review the code, you will do the due diligence and whatnot. But let's not go into that information now. So you commit the code. There is a build pipeline. That build pipeline will make sure everything works fine. And then they will push it to a repository. And from that repository, you can manual testing, approval, multiple steps to production. And then you can push it to the production, and your customers out in the world can see the changes. So this is what continuous integration is, right? Continuous delivery is that you build the pipeline and then somebody will approve the changes. Somebody will go and click on the button that, okay, go click to the dev box or click to the staging, click to the QA environment. And then after that is approval has happened, then only you will promote it to the production. Whereas with continuous deployment, as the name says, continuously deploy. You want to deploy to production. So the moment your build pipeline finished, it will automatically push it to the production. And the third one, is a little bit tricky, challenging, and risky one. So you need to be careful what you are choosing for. Now, DevOps is not something which works only with one programming language, or any provider out there only supports one programming language or on one platform. There are a couple of providers available like Jenkins, GitLab, GitHub, AWS, Azure, and many more. They all are sort of supporting each other, and if they are not, they are always in the catch-up race with each other. Nobody wants to be behind from anybody. So all are capable to launch anywhere, deploy anywhere, to any platform, written in any programming language and whatnot. So all those things, even something you don't see here, that thing is even available to be deployed using DevOps. Now, there are a few things I want to talk about DevOps metrics. Now, metrics are that how do you measure things, right? So if you do DevOps, your deployment frequency increases because you are not writing any document. You are not depending upon anybody to really have a documentation and whatnot. So your deployment frequency increases. As you can see this bar, it's increasing. Your change lead time. Change lead time means that how long does it take for you to deploy a change to a production. So let's say you received a new feature request or a bug, for example. How long will you take to really understand the bug, diagnose it, fix it, and deploy it? The change lead time really reduces because you are a DevOps team. You own everything. You do not need to write any documentation. Don't give it to somebody who does not understand how things work. It's your one cohesive team. We call it DevOps team. Many companies like Amazon has a term for that, call it two-pizza team. Means the size of the team is supposed to be which can be fed by two large pizzas, means like 7 to 9 people plus minus 2. And we have the same mechanism at T-Mobile as well. So your change lead time is really shortening or reducing with this entire concept. Now, change fail rate. This third one is very important to understand. Many times what happens when you are deploying and running really line of business applications, look at our T-Mobile website. We have a lot of data being pulled when you log in, not on the tmobile.com, but when you go to your My T-Mobile account where you see your lines and how many phone lines you have, you want to buy a new device, we activate your number and all that stuff we do, right? So whenever we deploy new thing, we want to make sure that we are not breaking your previous experience. And it's not only us, it's every organization out there, they follow the same principles. Now, whenever you deploy something new, the chances are that you might break something which was working just fine until this change went in. Now, since with DevOps, what you have is you have a very cohesive ownership, a sense of ownership. At T-Mobile, we call it, we build it, we own it. So I will repeat it one more time. We build it, we own it. That's what our motto is. So change fail rate is really going down very less and less, that whenever you make something changes, nothing will break because you have been continuously testing it, continuously monitoring it, always integrated changes, and then deploying to production in its simple stages and steps. Mean time to detect and repair. This metrics is also reduced because if there is even a bug in the system or you find some defect after launch or deploying to production, you can always fix it very easily because you are a DevOps team. So that time is also reduced significantly. Now, how does DevOps automation look like? So all these stages are there. So what happens is you check in the code, you trigger the version control, means you commit something. Now, let's say your build and testing failed, your unit test failed. Now, the moment you were compiling your code means your code was hustling with the rest of the code, which was checked in by your other peers and fellows in the team. Now, one of the unit tests failed. Now that feedback has popped up, your build failed, means your code is not merged into the bigger, larger repo. Your code is still isolated. And then that feedback is sent back to you that unit testing failed. Now what do? You receive the feedback, okay, unit test failed, why it failed? Oh, I didn't do this. Let me fix it. Again, you trigger your version control, you commit the code, it goes in, and then it triggers the automated acceptance testing. Acceptance testing could be much more larger integration tests, more wider tests, like boundary tests, and maybe trying to execute a synthetic transaction, trying to accomplish something. And then let's say that test failed. That said, okay, your unit level is fine, but I'm not able to do integration test with the rest of the backend systems. Now, that thing failed, again, you are not done. So again, you receive the feedback, you work on the feedback all the way, and let's say acceptance automated tests has been accepted and approved, and then your user acceptance testing is passed, and then after approval, you send it to the release, and that's how you deploy the code to the production. So there is a consistent cycle of feedback if you observed here, and you keep receiving the feedback, and then you continuously work and then deploy to production. Now, this is DevOps Toolchain. I will not spend so much time on it. So what happens here is that all these tools are available in different systems. At T-Mobile, we use Jira, Align. We use Confluence. We do use Slack. We do have Microsoft Teams also. And then for design, we use GitLab. Our IDE is IntelliJ. We have build release in GitLab. We use Jenkins also. And then we are on AWS. We use Docker and Kubernetes. We use SonarQube for static code analysis. We do use HP Fortify for security testing in our pipeline. We do use JUnit because we are using Spring Boot Java. We do have Selenium, which is a UI automation framework. If somebody is really passionate about UI and you want to learn how to automate UI, then learn about Selenium. Cucumber is another framework for behavior-driven design, little bit different approach for unit testing. And for performance testing, we do have our own load and performance test suites, which we utilize. Now, I also want to take some time and tell you that what will happen to these, some of the practices in category of quality of code check-ins, environment creation, and whatnot, if you are with and without DevOps. So let's say you are without DevOps, what happened to quality of check-ins? You don't know what is happening, who is checking in what, is it being validated, monitored? You don't know. But in DevOps, you can validate it through unit tests. It's a matter of debate. Somebody can argue, no, Vidya, I can still do it even if I don't have DevOps, and I will not disagree with that. But I think the point here is that how automated it is. The idea is with DevOps to remove human intervention. I do not believe in replacing humans with robots. That's not the intent what DevOps will have even in future. DevOps is all about taking your hands away from the things which you have done once, and then it keep utilizing it by itself without you really, injecting into the process. So in your pipeline, in your DevOps pipeline, you can inject unit tests, runs, and it will automatically do it. Environment creation, manual and automated. Remember, I was talking about infrastructure as a code. So here you have to really go and spin a virtual machine, and then give a document to somebody. That person will go and copy and paste the code on your virtual machine and then do it. In DevOps, you can write all the scripts, write it once, use it as many times as you want, or modify it once and use it as many times as you want, or create different flavors, maybe different strength of virtual machines. For a small thing, a small virtual machine. For big thing, a Godzilla virtual machine, right? All these things are possible, having different type of scripts available. So here it can be automated. I will quickly go through it. So deployment frequency is 1 to 2 times a month. That's what I have followed in the past. But today with DevOps, you can go several times per day. There are organizations like Netflix. They deploy I think every 4 seconds. I read it somewhere. I may be off a few seconds here and there, but that is so much in a sort of exaggeration. That is it? Can they deploy every 4 seconds? Yes, they do it. So how is it possible? Because they have DevOps, right? Deployment processes require meeting and planning, like I told you. I was doing that. Planning means writing documentation, long elaborated documentation, comprehensive. Here it's a push button deployment because your code is always ready to be deployed whenever you want. Even you can wake up in the night, click on a button, deploy it, and go to sleep. Deployment validation was manual. Here it is automated. Monitoring, almost none. There was no dashboarding, no monitors, nothing. Here we are consistently monitoring. At T-Mobile, we have even Slack channels where if one API starts failing or slowing down, we receive a notification on our Slack channel, and the people who are responsible will look, observe it, and see what is happening. And before it really go all the way down and drained and died, we will have some mechanism to recover it or fix it before it becomes a big issue for us. And Dev and Ops relationship, this is something like culture of blame, means you did not do your part right. I did not receive the right documentation. You did not write correct SQL script and whatnot. Here it's a culture of trust because it's one cohesive team which is working together. Now, there is something about cost of not deploying to just one server. This is history. It's a bug in the history of software system, which is documented here as well. What happened is back in 2012, in the month of August, there was one company that was writing algorithms and scripts for a stock exchange. In a stock exchange, what happens is a buyer wants to buy at a lesser price, right? And seller wants to sell at the higher price. So there is always a difference between buying and selling, and that is what the benefit or the profit is, right? So that's how it works. Now, in there, what happened in that company, they were having 8 servers where the code was deployed for the trading algorithm. And since it is trading, they wanted to mimic that. What happens if market sentiment changes and the value of the stock price go up or down? What happens to that? They wanted to like mimic it in their practice code. So they had some sort of algorithm in their production code, which had a flag. Flag means if this algorithm logic is on or off. So if the logic is on, then they will practice that logic, which is sort of dummy logic. But if that is off, that means use the live feed from the stock exchange, whatever price they tell you, sell on that or buy on that. So they did that sort of thing. Now, what happened is that they were deploying all that code manually to the servers. Means all the 8 servers were manually deployed the code. Like I was telling you, write a documentation, you say, okay, deploy to SQL Server. So only ops person knows how many servers we have, not the developer knows. At T-Mobile, every dev knows how many servers we have for which part. This API, this microservice is running on how many containers. I can tell you that. We have monitors for this. I can tell you if all the nodes of container and Kubernetes are up and running or not. So that's what DevOps is. But in my previous organizations, when even I was writing documentation, I did not know how many servers they are deploying to because 1, I was not supposed to know. 2, that was not the culture. And 3, that was not the DevOps team. These are 2 different separate responsibilities owned by 2 different people. So they don't talk to each other much. They only rely on a hand of a document and then you are done. If something failed, your fault or maybe other person's fault. So what their person did who was responsible to deploy, that person actually copied the new code, which was supposed to be deployed, and he deployed only on 7 servers. He forgot to deploy on the 8th server. So I hope you got the picture. Manual deployment, no DevOps practice. 7 server has new code. 1/8 server has old code with that flag on that you can tweak the price of the stock up and down, whatever you want. Randomly, it picks the price for whatever call is coming to buy or sell. Now, with that, you know there is a load balancer, and every request, load balancer decides the load of the traffic coming to the website. It can work on round robin. It can work on which server is closest to the user. So if I have servers deployed in West region in AWS and East region in AWS, the New York customer will be sent to the server or AWS data center region in East Coast, but a Washington, California, Portland, these customers will be sent to the Washington region of AWS. Unless Washington is down, then they will go to East. So there are multiple algorithms and mechanisms to decide which traffic will go where. Now, at any given time, traffic will always go to the 8th server as well, which has old code. And whatever traffic was sent to the 8th server, that server did the magic of reducing price back and forth. And within 45 minutes, this company, Knight Capital, acquired $440 million in losses. That was pre-tax. And they went bankrupt in one day. They had to work with some companies to raise the funding. Some companies came forward, and then they purchased that company in $125 million to pay their $440 million debt. So this was a very embarrassing incident for the Knight Capital CEO, Thomas Joyce, and this is all happened, and it's a real thing. It's very nicely articulated and documented on this website, Bugsnag, and this is recorded as the biggest bug in the history of software industry. And this all happened because of the manual deployment. Now, somebody can argue and debate, oh, is it not possible if we do DevOps? It is possible if you don't plug in that server. The thing here is in DevOps, if you are really doing it right, and always remember, there are so many practices and patterns and principles available out there, but somebody needs to understand what it takes bare minimum to do it correctly. If you do it correctly, there are no chances. Even if it happened, you have monitors to track it. And then you will know the moment it is started. You will not just sleep over it, that you never knew, and in 45 minutes, it was continuously running, executing orders of stocks, and made you losses in $440 million. It cannot happen if you are following DevOps properly. So this is a little bit about it. Let me do one thing real quick. I want to take some time and show you how this continuous integration works. So what I wanted to show you guys is that how this continuous integration works, how it looks like. Do you guys see my screen? I'm showing context.cshtml. Can
No,
somebody?
we are not seeing that.
Okay, all right. So let me bring it to this screen. I think that went away. Do you see that now?
Still no.
No.
What are you seeing?
We're seeing the slides.
Oh, you are seeing the slides.
You might
Yes.
have to reshare the window separately.
Okay, let me try that one more time. So I will share again. I just wanted to give you a little bit practical feel of it. That's the intent I have. What do you see?
Right now we
You.
see just
Nothing yet.
It says it's loading. Oh. Do you see now context.cshtml?
Yes.
Okay, perfect. Very good. So I want you to just pay attention, and then I think I'm almost done. I wanted to leave a good amount of time for you guys to either ask questions or leave early as you wish. So this is my last demo, and then I'm done. So I want you to quickly pay attention to a few things. Okay, so I'm here. Then I want you to remember this number. What number do you see here? So remember the last two digits, 3.6. Okay, remember this number, 3.6, and it says 50 minutes ago, as you can see here also, right? And then this is my Azure account where I have a website deployed. So I have this, let's say, I have this web, this is my repo, okay? This is my repo. Repo is where repository where your code is. So I do have an MVC application where my code is hosted. And let's say I go to views, and I just want to show you how continuous integration works. That's what I'm trying to demonstrate. And again, remember the last number was 3.6. So what I'm going to do is, if you are following, let's say, DevOps practices, then what you do is you make changes in your code repo. The moment you make the changes, it automatically triggers a build, and which will go through the entire steps. Remember, I have shown you a slide where you keep receiving feedback if test cases failed and what happened, and then you work again on it. Means if it failed, your code is not integrated with the larger repo. Your code stays in your local box. So here I'm mimicking that. So I say, okay, I want to make some changes, and I want to make it 1, 2, 3, and then 0, 1, 0, 0. And I say commit. So I commit, and there is no work item link because it's not connected. But if there is a work item, then you will be able to see a user story here. So I say just a comment here. I say contact number changed. I say commit. I am done. I shift here. Now keep staring on this page. This is my CI, continuous integration page. Did you see it says load one new run? Did you see this thing popped up by itself?
Yes.
This thing here. Remember the last was 3.6, so this thing popped up. I click on it. Now see that 3.7? So see that stage, it's running right now. So I open it for you guys. And this is phase 1, it's running. So look at it. This is what exactly now doing in continuous integration. So it is working on all the dependencies and going to find all the packages, means the dependencies I have used, your MVC package, maybe you use Redis cache, you use some sort of logger, whatever you use, it's going to bring all those dependencies from the NuGet package manager. So each phase you will see, each phase should have a sort of a checkbox on it. It's not building solution. Building solution is like compiling. If you are using C, C++ or any language, a compilation and build, these are almost same term and terminology. This is written in C# and MVC on Microsoft.NET. So Microsoft uses the term build, other programming languages use the term compile. And then now it is executing tests. If tests pass, then it goes to next step. It's now publishing symbols, means it's publishing the artifacts now. It's working on that. And it's published, so it's all done, right? And not only that, so if I tell you that what I was doing in my previous company, when not previous to previous, where I was writing documentation of deployment, so I will compile that code locally in my box, in my laptop, and I will give them something like this. You see this artifact, this is a drop folder it's on the cloud right now. It's not on my local box, it's on cloud. It's on this repository, which I'm mimicking like how many companies have. So at T-Mobile, we have something like tmobile.com/something something. So this folder, I will copy this folder, this zip file, and put it on that folder where ops person will read my document and deploy it. But here, I'm not doing it. I can deploy on my own. And after successful deployment, the website will open and it will look something like this. Right? So this is what it looks like when you do the CI/CD practices. So I want to thank you, and I wanted to leave some time, so we have almost good 13 minutes. You can ask questions or anything you have doubts about. I would be more than happy to answer those for you.
Thank you very much, Vidya. So I would ask the people who have questions to, just to make it more interactive, to please turn on their video, their camera, while asking a question. So I would just like to open this round and go ahead and let people ask some questions now themselves.
Juan, go ahead.
Juan Chavez, he has a question. What are your thoughts on SRE versus DevOps, and which types of business should employ each?
Okay. So SRE stands for Site Reliability Engineering. It's sort of a role by itself. At T-Mobile also, we have some people who are expert in SRE. In my view, DevOps is more aligned with the development side of the house, when you are still doing development and deploying sites and things like that. Whereas site reliability engineers are people who does have a very good understanding of the operations side with developers, but they are beyond the DevOps. For example, one good practice of SRE is a chaos monkey. So chaos monkey means you are creating chaos by yourself in your production workloads. You will inject some sort of bug in your system and see how systems react to it. You will intentionally bring server downs and see what happens to the customer requests and things like that. So if somebody is really passionate about writing YAML scripts and playing with different tools on operations, monitoring, dashboarding, and writing those things, but not the programming language and so, then somebody can really try to go towards SRE that also has some sort of scripting. But if you are more on the development side and programming and problem solving, then you are on the DevOps side of the house.
Okay, thank you. So Juan had another question. Do you try to limit the scopes of each product in the backlog to 2 weeks? How do you accomplish that? What happens if it cannot be accomplished or delivered in this time frame?
It's a very intelligent question, whoever asked. It's a very important question. And my intent for such sessions with you guys especially is that you get the feel in industry what is happening in today's world. So what we do is we are always 2 weeks, okay? Whatever we can get in 2 weeks. But as you laid out the question, how do we get which thing to be done in that 2 weeks? So in Agile, there are two backlogs, okay? One is, we call it just the backlog, okay? Just the backlog. And the second term is a sprint backlog. So I have a backlog and then I have a sprint backlog. This backlog is something where business and all the other stakeholders who represent end customer keep writing the work, keep putting user stories, features, epics. I want this to be done. I want that to be done. I want moon. I want the stars. I want Earth to rotate the otherwise. Whatever they want, they will do it. And then they will also write user stories. Okay, if customer goes during the COVID-19 times to T-Mobile website, a pop-up will come that please subscribe, give me free 20 GB data plan, like we did recently, or subscribe to call some of the COVID impacted countries free of cost, whether it's international calling, we won't charge you. We did that. Now, when these things are happening, these business customers also attach a priority to it, that what priority it is, how important it is, and what are the timelines to it. Then when they are writing this, there is an interface between, we call them product owners. Product owners are directly looking over this product backlog and seeing what is coming our way. And then they take those stories out and put it or slide it into the 2 weeks backlog. Now, if that team thinks, then that team will gather together in a big meeting room and go through story by story by story and see, okay, this story will take me 5 story points, means 8 days to finish it. And we have multiple developers who will, divide and conquer, and we can do all that. Then well and good. If not, we go and renegotiate the priorities with the product team and they go back to the business. The other solution to that is we take help from the other development team, because at T-Mobile, like, we have thousands of teams. In every team, there are hundreds of teams, or a few dozen teams at least, right, which are working on this. Then we will give some work to other teams to get it done, and then we will push it all together. I hope I answered your question. It might be long-winded, but I give you the complete picture how it flows and how developers handle that load.
Thank you for that. That was very illuminating.
Okay, good to know. Thank you.
Yes, very clear answer. He also asked, how do the sprints line up with continuous integration / continuous delivery or deployment? I guess you already said a little bit about that too. That was another question.
So, do you want me? I'm sorry. Do you want me to answer that question?
Yes.
Okay.
Yes. Go ahead.
So okay. So the reason is, even though I explained what is CI/CD and all, so what happens is many times, as I was giving an example earlier, that you do not want to deploy everything at the moment you have it ready. So what happens is we have a mechanism that we are following continuous integration and continuous delivery, but we do not do continuous deployment. So continuous deployment happens only on the night of deployment when we are ready to go. And I will give you a little bit more a logical answer to that. At T-Mobile, we have 23 domain teams which work together at any given time. When I say what are those teams, so I belong to the customer interaction domain. Whatever is see out there, or whatever our customers see, I am also a T-Mobile customer. I have a T-Mobile plan. Whatever our care reps see when you dial 611 from your phone, what they see, and what our retail stores see in their laptops and their tablets and whatnot in the Magenta stores, if you have been to any T-Mobile store. All those applications are written and owned by the frontline and business experience team. So earlier I was with frontline team, now I am with business experience team. Frontline is B2C, yani business to customer, like a local consumer, and a business experience is B2B, like to business, like where I am working right now. Now, what happens with these teams is whatever they are doing, unless it is a functional change. Functional change means I'm just changing a logo design. I'm just changing some verbiage of text. I am just adding a different image of an iPhone, or a new color came, I'm adding just that color. Then we can deploy it whenever we want. But if I am adding, and I have been part of those initiatives, for example, we are enabling contactless payment. You go to a store, you tap your credit card, and payment is done. I was part of it initiative. Now, if you see, this initiative cannot be done by one team. Only I cannot do it. So my UI will show, oh, you can do contactless payment. So some sort of logo will come with a hand or some sort of waves behind the credit card or on the screen, which tells our rep or the customer that you can do contactless, or it will say insert credit card, right? So for that, we need to get engaged with our payment team. Payment team need to tell, yes, my APIs are ready. When you will inject the card, we are able to do this thing, or when you will tap the card, we are able to do this. And even which type of card we are enabling it first. Sometimes we have dependency on other domains that we can do only Visa and Master right now. We cannot do Amex and Discovery. Then we have to follow up with other teams. So we have a lot of ripple effect of whatever we do. And hence, even though we are ready with continuous integration, which is of course the bare minimum thing everybody should have, then continuous delivery, which we always do, and then deployment, we agree upon one common date by all the VPs approval and all, and payment will deploy first, and then we will deploy first, and all the domains will stay active that night to watch the traffic, process the test transactions. When everything looks good, all the VPs have given approval, then we open the traffic for the public. And that's why it happens in the off business hours in the night. But it takes like few hours, usually 1 or 2 hour window we keep.
Thank you so much. So we have another question from Xin. Would you like to turn on your video? Great.
Yes, I can ask him about it. So you mentioned about the barriers between the two DevOps teams and when they're working together. And then what are some example of the barriers, like which is a challenge in the DevOps? I know that you mentioned about that, like your previous answer was sort of connected to my questions, but I'd like to know the major of the barrier.
So still what happens is like, if I want to be really honest and I want to give you honest answers, the best DevOps team is a team which has only 7 to 9 people. The other word for that, which Amazon came up with, is called a two-pizza team. Always remember that. You need to know industrial terminology, what big leaders in today's world, what they are calling it and why. So the biggest barrier is even in DevOps is that many times developers do not know what our ops person is doing, even within DevOps. Many times we ask them questions, or team asks them questions, which even they don't know how they are doing it. A lot of things are not visible to the developers. So these are the barriers. Other thing is, where is monitoring? So I'm a dev, I'm so heads down, I'm so busy with my daily work that I have no time to know what I build, how it is impacting life of my customers. Is there a dashboard for that where I can see how my own written API or REST API or microservice is performing? Can I see that? And these things, I call it growing pains and a culture. That's why DevOps is a culture. You know, we have a culture, but how strong and rich your culture is, it's up to that team and that individual and that group of people, right? And that's why it is called culture. Now, even though you adopted it, but your culture may not be very rich if you have a larger team. So keep your team size small. Make sure that all those dashboards, monitoring guides are published, and every developer knows where are my APIs and how to see it. So these are some challenges I have seen. I have seen in T-Mobile as well. We are always observing and cognizant to such things. And we try to make sure that all our devs know everything, and we have good monitoring in place, which everybody knows. Anybody in the team can go and see on that monitor and dashboard what is happening. And the other thing is having access to the production environment, really knowing and seeing the continuous integration pipeline, which anybody can see. So earlier in some teams, what happened is that a developer will only check in the code, but that developer cannot see the steps which I have demonstrated to you guys on the screen. They were not able to see it because Your code was going to a bigger code repository where I made the change. And then from there, it will trickle down to the continuous integration pipeline, which only the ops people of your DevOps team knew. Very recently at T-Mobile, we adopted to GitLab. It's a pretty cool tool which brings every single thing under one roof, multiple solutions under one umbrella. There, anybody can see the CI/CD pipeline. But to be sure that not everybody can do everything, we have given some permissions that only people in our 7 to 9 people team, the people who are ops, wearing ops hat, only has access to production. So just error is to human. So by mistake, nobody can push code to production. So that's why we have done it. But now everybody has everything. And those are some barriers, some challenges I have seen. And I also told you how we at T-Mobile are trying to overcome those.
Awesome. Thank you so much.
You're welcome.
My question is, what is the responsibility of DevOps team leader? Because I didn't see the first 20 minutes. I'm curious about the roles in DevOps team. Could you talk about that?
So when you said you did not see first 20 minutes, did you mean you did not join first 20 minutes?
Yeah.
Okay. Okay, I was not clear what do you mean by you did not see, but I take that I did not talk about roles because roles depend on team to team, but it's a very fair question. I appreciate that. It's a good question and a valid question to be asked. Though my intent was not to cover that in my presentation, and that's why I kept it open to ask questions. So let me tell you. So when we say 7 to 9 people at T-Mobile, we do not have multiple roles in such a way like many organizations do. But yes, we do have multiple roles. For example, I am an architect. So I am involved with a couple of teams. I have my peer architects, my other colleagues at work. They all are connected with different teams. So in any DevOps team, even though it's DevOps team, you always have some roles which are always there. And there are some roles which will come and go. So like architects are usually come and go. They are like on demand basis. So you cannot count me or an architect as a DevOps team candidate. Okay. Now there will always be a Scrum Master, first of all, because if you are doing Agile Scrum, you have to have a Scrum Master. There will be a product owner who will talk to business and look at the backlog and then work with business to define priorities, define user stories, initiatives, epics, features, user stories, and whatnot, and then help the team to bring it to the sprint backlog when they are ready to get it done. Then there will be a dev lead. Now we have like 2 types of dev leads. One is the functional dev lead on the UI front end. We are using Angular. Many organizations are using Angular, React, and JavaScript and whatnot, TypeScript and all. And then there is an API. So we have microservices, and there is a API dev lead who knows about microservices. In some teams, we have only one dev lead who knows both, like a full stack developer. Then there will be an analyst. There are 2 types of analysts. One is a functional analyst who only knows about front end, who dictates and defines on your payment page, how would payment page look like when you are ordering something from your home? How does it look like? You have a credit card number and a text box to enter credit card information. You will have expiration, year, address, zip code, all those things. On the other side, there is a technical analyst. Technical analyst defines what API needs to give back when user interface or the front end is calling. So front end passes the credit card number to that microservice. Microservice receives that information and send it back to the digital payment services team for processing of that payment from the credit card. So there is a technical analyst. Many times in teams, only one analyst can do both the jobs, or sometimes they have 2. And then there will be a QA, quality assurance or testing, or sometimes we have manual testers, sometimes we have automation testers in one team. And that's what the bare minimum composition of a DevOps team, which we at T-Mobile have. And then architects, as I said, come and go. Managers own the teams, so they are not part of the DevOps team, but they own that team, which is delivering one particular capability or feature. I hope I answered your question to some extent.
Yeah, thank you. Thank you.
You're welcome.
All right. Thank you. I do have another question. So you basically described DevOps as a culture that entails tools that helps companies to apply or their strategies more effectively. So does it vary from your experience from company to company, the way they employ this DevOps culture?
Yes, it's a good question as well, Alina. So as I said earlier, the reason it's called culture, and as you know, like we all have some sort of culture, right? So culture is something which can be how much mature it is, and how it is helping you to deliver value you want to have. So some companies have that culture so much mature, like Netflix, for example, that they are capable to deliver every 4 seconds. It's insane if a company is doing that. And look at how they are streaming applications. Think about how many servers they might be having. Look at Facebook, how do they do live streaming? And similarly, look at T-Mobile. When we went live for Apple launch, our site didn't go down even for a single second, whereas all our competitor sites went down. Even I heard in the news, even Apple site was down. So, but T-Mobile site stood strong and sturdy there whole night to take the load, and we received like almost over 100,000 orders to process Apple phones, the pre-order, right? So it's the culture where you keep achieving maturity. There is no, it's not written in the stone that if I am doing this, then I am done. You always keep looking for what you can get better at. Keep pushing the limits. And that's why somebody asked the question about SRE, and that is where those practices come into the picture. So when you talk about SRE, those SRE site reliability engineers keep looking for the areas, how do I break your website? Let's say I'm processing the order, you are in West region, you added something to the cart, but West region went down, right? My site went down, what do I do? How do I transfer that customer right away to the East region? There might be a little bit delay, few hundred milliseconds, but the person will still be able to process the order. And in the meantime, we are recovering the West website. So all other customers from the West region can start sending order to West, right? So these are the levels of maturity we try to achieve.
Okay, got it. Thank you.
I have a question. This is Clark. So currently our students are have finished with Linux materials, CompTIA materials, and they're currently studying networking. So what is the learning path or the knowledge gap that they have to learn to learn DevOps? So any tips? Yep.
So I got it, Clark. I think that's a fair question. So as I said, DevOps is not a technology or anything. It's a culture, right? The only thing, since you asked what they need to learn, is try to make yourself aware of the things like continuous integration, how to write unit tests. For Unix and your networking people, it's very hard because I know in Unix you can write a lot of scripts and all. I don't think anybody is using Unix today on daily basis like that. I have used it long ago. But if somebody is in programming, then it's very easy to adopt to a DevOps culture and practice it on daily basis, even though you can do it at home. But if you have any scripts or anything, at least make yourself aware of how do I check into a code repository. If there is a way to test your script, do that. If you have networking and you are playing with virtual machines and all, then learn about the automation scripts. Like Terraform is one tool which can automate the virtual machines. All the cloud providers today provide you scripts to automate the same virtual machine. There is a term called YAML. YAML scripts are there to spin a virtual machine automatically. And since you mentioned networking, I would highly recommend go beyond your on-premise, means go beyond your physical servers. Try the same thing to do how it happens in cloud. That will be, I think, a path towards DevOps, because when you go in a team setting which is on DevOps like T-Mobile is, whatever we do is on the cloud. We do not do anything with physical servers at all. All our virtual machines, serverless, containers, Kubernetes, everything is in the cloud only. So make yourself aware of that. That would be my 2 cents to this. But if needed more advice, I can provide offline. But I think that is my quick 2 cents to that.
Thank you.
You're welcome.
All right. Do you have any more questions, guys? So I'm seeing nothing more in the chat. Last call.
Yeah, if we're about to be done, and just any last words from Vidya, like a very like a main takeaway, if for those people who still is new to this and can't understand.
So, I mean, the only thing is, as I said, it's a culture. So do not think of it's a tool or product you can buy. Just to learn about it. It's very simple. DevOps is not a rocket science thing. Keep doing what you are doing. Just try to make yourself, how do you fit yourself into a larger puzzle in larger companies, how they are doing things, and look out of the box in your daily basis. Many times problem we have is we like to do what we keep doing, but we don't see how my work impacts the entire team. So if I am a developer and I keep writing code, which is fine, but if you're not writing unit tests, then how do you contribute to the team's success to be a real DevOps team? So just think a little bit out of the box, and learning is very important. So learn about these things. You can read blogs. Anybody, I have written a couple of those. You can read any book, any tutorial, anything you want. I have a complete video on the same thing on my YouTube channel as well. If you want, you are more than welcome to go and have a look at it. And then just learn, talk to people how they are doing it, getting some real industry perspective from people you connect with always helps, because that put you into their shoes. And you, without doing that, you learn from them how they are doing it. So if you go somewhere, talk to people, interviews, going out in industry in future and work, you will know how companies work. Even if you have not done it, at least you know how they do. And some skills are coachable, so I greatly believe in that. So learn the skills, and whatever is coachable, you will be coached and trained by your future employer as well.
Great, thank you so much. Very good takeaways. And looks like we have no more questions. So thank you very much again for your time. We really appreciated it, and we're happy that it worked out on such short notice too. So yeah, that was a very insightful talk, and I feel like I learned a lot. So I'm going to share this recording with everybody after it's done, and I hope we will see you again in the future.
Sure thing. I look forward for that. Thank you so much, Elena, for inviting me, and the CTU team. Really appreciate it. And you can always connect back with me on my post on LinkedIn. You can put your questions. I try to closely watch all the comments coming. I will try to answer. If there is anything come back to your mind later on, or any thought-provoking questions come to your mind, I will try my best to answer over there. Thank you so much for having me, Elena. Really appreciate it. You guys have a good day.
You too. Bye, guys.